imagine waking up to, like, a PagerDuty alert at 3 a.m.
Oh, always the best time.
Right. But it's not your primary database going down.
Right.
And it's not, a sudden spike in server traffic.
Okay, so what is it?
It's literally a while loop. Just a while loop holding a corporate credit card
Oh, no.
that just spent, like, $4,000 trying to parse a 404 error simply because it, hallucinated a non-existent API endpoint and just decided to retry it endlessly.
Yeah, just burning through cache while you sleep.
Yeah.
Terrifying.
Exactly. And look, if you are writing code right now, the hype around AI agents feels completely inescapable. I mean, your feed is probably just saturated with promises about autonomous agents that will, like, rewrite your legacy code base.
Right, or handle all your customer support by tomorrow.
Yeah, or just magically self-heal your entire infrastructure. But beneath all that exhausting marketing buzz, an agent is fundamentally just software.
Just software.
And software has to be architected, debugged, deployed, and monitored. So we're dedicating this deep dive to basically cutting through that noise.
I love it. Taking the hype machine completely offline.
Exactly, taking it offline. Our mission today is to explore a real, practical, bare metal guide to building your very first AI agent. We are going to deconstruct the core architecture, look at why you should probably, delete those heavy agent frameworks you just pip installed.
Which is going to be a controversial take for some people, I'm sure.
Oh, absolutely.
Yeah.
And we're going to confront the harsh realities of production. Stuff like observability, tool overload, and the actual architectural mechanics of token management.
Because, the magic of the demo environment, it vanishes entirely the minute you try to keep one of these systems running in production.
About incinerating your cloud budget.
Exactly. It's a massive paradigm shift. We are so used to deterministic programming.
Yeah.
Strict control flows, predictable outputs. You put X in, you get Y out.
And this is not that.
No,
Yeah.
not at all. But the funny thing is, the complexity of these systems doesn't actually come from the individual components. The building blocks are remarkably straightforward. The difficulty arises entirely from how those simple components interact dynamically in an unpredictable probabilistic loop.
So let's start there. Let's define that irreducible core. If we strip away the shiny UI, the complex system prompts, all the buzzwords, an agent reduces to exactly 3 fundamentals, right?
Just 3, yeah?
A language model for reasoning, tools for interacting with external systems, and a loop. A loop that just continuously drives the process until the defined task is marked complete.
That's the whole engine.
Right, and for anyone spending their day inside an IDE, the most accurate mental model here isn't like a synthetic brain with digital hands.
No, definitely not.
It is literally just a while loop.
Mm-hmm.
But in traditional software, your while loop runs on a rigid Boolean condition. Like, while x is less than 10, keep iterating.
Right, simple math.
But an agent is a while loop where the exit condition is governed by a reasoning engine.
Which is wild when you really think about it. The condition being evaluated isn't, Boolean equals true. The condition is the model continually assessing the current state of the environment against a user-defined goal.
Right.
It looks at the context and decides, have I achieved the objective?
So it's basically while task is not complete.
Exactly. And inside that execution block, the agent takes a specific action, observes the results of that action, and the loop iterates.
It evaluates the new state.
Yeah, it looks at the delta between the current state and the ultimate goal, and then it formulates the next operation. That loop is the heartbeat of the whole architecture.
And that's where it gets so weird for traditional software engineering. Because normally, if a function fails, it throws an exception.
Right, you get stack trace.
Yeah, you might have a try-catch block to handle it gracefully, or the app just crashes. But in an agentic loop, if a tool fails, say, an external API returns a 500 internal server error, the agent just receives that error payload as a string of text.
It literally just reads the error.
And reasons about it. It might decide to wait and retry the exact same endpoint, or it might pivot and use a completely different tool.
Right, it's adapting on the fly.
Which sounds incredibly resilient on paper. But handing the steering wheel of your execution thread over to a probabilistic model, that introduces an entirely new class of bugs.
Oh, absolutely.
And if the architecture relies this heavily on just a loop, a prompt, and a series of API requests, it raises a massive question about implementation. Because the immediate instinct for any software engineer, my own included, is to reach for a framework to handle the boilerplate.
Yeah, the NPM install reflex.
Exactly. But pushing back against that instinct is the core of the raw API's first philosophy we're looking at today. The recommendation is to completely avoid frameworks when you're first learning to build these systems.
Which I strongly agree with.
Well, wait, I have to challenge that heavily on behalf of everyone listening.
Okay, let's hear it.
Software engineering relies on abstractions. That is the only way we scale our productivity. I don't write my own load balancers from scratch. I don't write custom database drivers.
Yeah, hear it.
If I need to build an agent by Friday, LangChain is sitting right there. Crew AI is right there with like thousands of stars on GitHub and pre-built integrations for everything.
Sure.
Why would I ever revert to writing raw HTTP requests just to build an agent?
Because abstractions are designed to hide complexity, but the abstraction layer of an AI agent is notoriously leaky right now.
Leaky out.
Well, the underlying technology is still in its infancy. If you use a heavy framework to build your first agent, you are entirely obscuring the fragile mechanics of the system from yourself.
Okay, but
Think about it. When an abstraction leaks in a traditional web framework, you can usually drop down a level and read the source code. When an agent framework leaks, you are left staring at a black box.
manually parsing raw JSON from an Anthropic or OpenAI model. I mean, are you seriously suggesting I write custom regex to catch trailing commas or missing brackets just to get a prototype running?
It sounds painful, I know.
That sounds like an absolute maintenance nightmare.
It is a maintenance challenge, yes. But consider the alternative failure mode inside that framework. At its core, the agent is just outputting text, right? Usually formatted as JSON. That dictates which of your local Python or Node functions to execute.
Right, the tool calling.
And that formatting process fails constantly. The model hallucinates a tool name that doesn't exist. It forgets a required parameter in the schema. Or it just invents a new parameter based on its training data.
Yeah, I've seen that happen.
When you use a massive framework, that failure is handled behind the scenes. You either get a generic, unhelpful error message, or worse, the framework's built-in retry logic kicks in.
Oh, and it just loops?
Yes. It quietly burns through thousands of tokens trying to fix the JSON without ever alerting you to the underlying prompt deficiency.
Okay, wow. So you are advocating for literally using standard HTTP libraries, or at most, the bare bones provider SDKs, and manually writing the while loop yourself.
Exactly. You manually construct the JSON schema for your tools. You send the request. You manually parse the model's response. You route that parsed response to your local function, execute it, and then manually append the result back into the message history array.
And then send it back to the API for the next iteration.
Yes. The value there is in feeling the pain of the integration.
Building character, basically.
Basically, it forces you to understand the exact structure of the payload going over the wire. You see the role user, the role assistant, and the tool calls array in their raw forms.
Okay, I see what you mean. Because when a deployment breaks, and it will break, you have to debug that fundamental interaction between the system prompt, the token output, and your execution environment.
Exactly. And if you understand those raw mechanics of how tool schemas are serialized and sent to the API, you can graduate to those larger frameworks later.
But with actual intuition.
Right. You'll have a genuine intuition for what they are doing under the hood. You'll actually know how to configure their retry mechanisms or override their parsers.
Okay, I'm sold on the raw APIs. Let's assume I've built this manual loop. I take it out of my safe, predictable, local development environment, and I deploy it.
Good luck.
Right. The immediate blocker I'm going to face is observability. Because standard application logging is completely inadequate for this architecture. We really need to talk about this flight recorder concept.
Yeah, the flight recorder is non-negotiable. Think about the debugging experience we discussed earlier. When an agent crashes at 3 a.m. while migrating a database, traditional logs are useless.
Because the code didn't technically break.
Exactly. There is no null pointer exception to track down. The model executed your logic perfectly, but it did so based on a completely irrational, hallucinated premise.
So you are staring at a dropped database table with absolutely zero visibility into the model's decision-making process.
It's terrifying, which is why you must log the exact state of the context window at every single iteration of the while loop.
Every single iteration.
Every single one. You need an immutable record of the system prompt, the exact tools that were available to the model at that specific millisecond, the raw text output, and the exact data payload the tool returned.
Wow. So we're essentially reconstructing a probabilistic thought process after the fact.
Because the engine is probabilistic. Running the exact same initial inputs twice might yield a completely divergent execution path.
Right, because of the temperature of the model.
Exactly. So to stabilize the system, you pull these flight recorder logs, pinpoint the exact iteration where the execution deviated, and analyze the context.
You're asking, why did the attention mechanism weigh this specific tool as the optimal choice given this exact context?
Yes, and often the solution isn't changing your code, it's rewriting the textual description of the tool in your JSON schema so the model better understands its purpose.
Which naturally introduces the problem of tool overload and the search space.
Mhm.
Because my immediate instinct, if I see my agent failing to answer a question, is to just add a web scraper tool to its arsenal.
Just throw more tools at it.
Right. Give it more capabilities. But the source material is adamant that adding tools one by one and testing heavily is critical, because giving an agent more tools actually increases the probability of catastrophic failure.
It completely defies how we manage human engineering teams.
Right. If you give a developer more administrative access or more debugging tools, they become more capable of resolving complex incidents.
It's the Swiss Army knife approach.
Yeah, I want my agent ready for any edge case.
Yeah.
Why does expanding its capabilities degrade its performance?
It fundamentally comes down to how a transformer's attention mechanism allocates weights across the context window.
Okay, break that down for me.
Every time you register a new tool, you are appending a new block of text, the tool's schema, the description, the parameters into the system prompt.
Right.
By doing that, you are drastically increasing the denominator of possible actions the model must evaluate.
You're cluttering the context window with competing options.
Exactly. Let's visualize an agent with just two tools. Let's say query customer database and send mail update.
Very
Right. It is computationally trivial for the model to differentiate when to use which. Now, expand that. Let's add search public web, query internal vector store, read locale file, and get calendar events.
Okay, getting messy.
When the user inputs a complex prompt, the model now has to evaluate a massive, highly overlapping search space. Should I search the web for this? Or check the internal vector store? Maybe the database has it.
Oh, I see.
The probability of the model selecting the suboptimal tool, or worse, getting paralyzed and infinitely looping between two similar tools, just skyrockets.
It is algorithmic decision fatigue.
That's a great way to put it.
And an agent crashing because it selected the wrong tool is a frustrating bug. But an agent stuck in an infinite loop, rapidly switching between the vector store and the web scraper while holding your API keys.
Now we're back to the 3 a.m. pager duty alert.
Exactly. That is an existential threat to your infrastructure budget. Which brings us to the absolute necessity of building a financial fortress around the agent.
The hard budget ceiling and strict token management. You can't skip this.
Because every single iteration of that while loop is a network call to an API provider.
OpenAI.
Anthropic, Google.
Yeah.
And every call incurs a cost for both the input tokens and the output tokens.
Right.
If the loop doesn't have an exit condition that forcefully terminates it, it is a slot machine that never stops spinning.
And it's worse than that because the context window grows continuously.
Oh, right.
With every single iteration, you append the model's previous response and the tool's result back into the array. So the cost compounds non-linearly.
That's brutal.
The first iteration might cost fractions of a cent, but by the 50th iteration, you are sending a massive payload, and the cost per call becomes highly noticeable.
So we have to implement defensive coding constraints immediately. Adding an iteration limit is straightforward. You just instantiate a counter outside the loop, and if iteration's 10, throw an error and break.
Simple enough.
But the architectural advice around caching, and specifically truncating tool outputs, is much deeper. How exactly does truncating a tool's payload save the system? I get the cost aspect, but is there more to it?
Let's examine a common scenario. Say your agent uses a tool to search a company's Confluence wiki for API documentation.
Okay.
The query executes, and the wiki returns 5 massive articles totaling 30,000 words.
A massive JSON payload coming back from the tool.
Right. If you naively pass that entire 30,000 word block back into the context window for the model to process, yes, you pay for every single one of those tokens. But more critically, you severely degrade the model's architectural ability to reason.
Really? How so?
Transformer models frequently suffer from a phenomenon known as lost in the middle.
Lost in the middle.
Yeah. The attention mechanism heavily weights the tokens at the very beginning of the prompt and the very end.
Oh, like a primacy and recency effect.
Exactly like that. The information buried in the middle of a massive block of text loses its weight. The model literally forgets the original goal because its context is flooded with all this raw wiki text.
Wow. So truncation isn't merely a cost-saving measure. It is a strict architectural necessity to maintain the model's reasoning capabilities. We have to actively step in and intercept the payload.
You have to. You implement a utility function that monitors the tool's return payload. If the string exceeds a specific token limit, say 2,000 characters, you slice the string, discard the rest, and append a hard-coded system note.
Like result truncated for length.
Yeah, result truncated for length. Please refine your search query to be more specific.
I love that. You are actively forcing the agent to be a better software engineer. You are returning an error state to the reasoning engine that basically says, your database query was entirely too broad. You asked for everything. Try again with a sharper knife.
Exactly. You are applying guardrails to the autonomous loop. And caching functions on a very similar principle. It's just applying traditional software optimization to a probabilistic environment. If your agent repeatedly queries the same static configuration file during a task, there is absolutely no justification for paying the API to format the tool call, paying for the network latency, and paying for the input tokens again.
You just intercept the tool call at the application layer, check your Redis cache, and return the payload instantly.
Exactly. Save the time, save the money.
And sitting above all of these micro-optimizations is the ultimate fail-safe, right? The hard budget ceiling, the centralized kill switch.
The panning button, yes. If you are running a multi-agent system where different loops are passing context to each other, local iteration limits aren't enough.
Because agent A could pass to agent B and they just loop forever together.
Precisely. You need a centralized token counter-tracking the aggregate spend across the entire application runtime. If that counter hits $50 for the day, or whatever your predefined threshold is, it forcefully terminates the execution environment. Hard stop.
Which introduces a brutal reality for production deployments. A hard budget ceiling is absolutely necessary to protect the company, but it guarantees that your application will fundamentally break for your end users the moment that limit is breached. It is a completely blunt instrument.
It is. But a degraded user experience is always preferable to a catastrophic cloud billing event.
I mean, you're not wrong.
And it perfectly highlights the core tension of the current technological landscape. We are building systems designed to operate autonomously, but we cannot fully trust their execution paths yet.
We're in that messy middle phase.
Yeah. Mastering these specific constraints, the rigorous observability of the flight recorder, the aggressive curation of the tool search space, and the strict token management, that is the absolute foundational requirement for the shift happening in the industry right now.
Because we really are looking at a massive transition. We are moving away from simple reactive chatbots that just answer questions in a UI toward autonomous workers.
Agents doing actual labor.
Agents that operate asynchronously in the background, executing complex, multi-step, long-running tasks while the user is completely offline.
And that transition from an assistant to an autonomous worker is gated entirely by trust and reliability. The engineering challenges we just discussed, the hallucinations, the infinite loops, the tool decision fatigue, those are the ultimate trust hurdles.
Right.
Until you can trust an agentic loop to reliably execute a 5-step deployment process without requiring a human to manually verify every single state change, you cannot delegate meaningful engineering work to it.
You just can't.
Oh.
So to bring this all together, we've completely stripped away the magic today.
Hopefully.
An AI agent is a while loop, powered by a transformer model evaluating state, with API hands to interact with the world.
That's the bare metal.
You have to write raw HTTP requests and parse the JSON yourself to truly understand the mechanics before you trust a framework to abstract it away.
Embrace the raw APIs.
You must implement a flight recorder that logs the exact state of the context window at every single iteration. You have to be incredibly stingy with the tools you provide to protect the model's search space.
Less is more.
And you must build a financial fortress around the application with strict truncation and centralized budget ceilings.
Because defensive engineering is the only thing that separates brittle prototypes from resilient systems that actually drive business value.
Well said. Here's a final thought for you to mull over as you jump back into your IDEs today. If we are engineering these autonomous software loops that require such rigid iteration limits, aggressive tool curation, and literal budget ceilings just to keep them from destroying their own execution environment.
Right.
At what point does debugging an AI agent stop feeling like traditional software engineering and start feeling a lot more like managing a highly enthusiastic but deeply unpredictable new employee?
That is a fascinating parallel for the future of our industry.
Keep that comparison in mind the next time you're analyzing those flight recorder logs. Thanks for joining us on this deep dive.